Welcome to the Deep Dive, where we take you straight to the bleeding edge of AI research, rediving deep into arcv.org, bringing you the latest and greatest papers that are making waves in the AI community.
Buckle up because we've got a lot to cover, from algorithms that can predict the future even when the rules change to AI that could help us design a more sustainable world.
Let's start with predictions. AI is getting pretty good at forecasting, right? But there's a catch.
There's always a catch.
What happens when the data the AI is trained on doesn't quite match up with what's actually happening in the real world? Like, you're using a weather app and it tells you it's sunny, but then, bam, you get caught in a downpour.
Right, that's what researchers call a distribution shift. Basically, the model's training data doesn't reflect the current conditions.
So it's like training a weather forecasting model in sunny California and then trying to use it in, say, Alaska, where the weather's completely different.
Exactly, and that's where this paper, Conformal Prediction under Levy-Prokhorov Distribution Shifts, comes in. They're trying to make AI predictions more robust, even when the data is shifting.
So how do they tackle this problem of distribution shift? What's the secret sauce?
Well, they use this technique called Levy-Prokhorov ambiguity sets. It's a bit of a mouthful.
Yeah, it is.
But essentially, it helps the AI model account for changes in the data, big or small. So even when things are changing rapidly, the AI can still make accurate predictions.
Okay, I see. So this could be huge for a lot of things, right? Like self-driving cars that could adapt to sudden weather changes or financial forecast that can account for market volatility.
Absolutely. It has implications for pretty much any field where accurate predictions are crucial.
This is pretty exciting stuff. And speaking of exciting, let's move from accurate predictions to optimizing for a better future, which is where the next paper comes in.
Right. The paper is called Multi-Objective Bayesian Optimization for Networked Black Box Systems, and it introduces this algorithm called MOBONs, which could be a real game changer, especially for industries struggling to balance profit with sustainability.
MOBONs. It sounds like a superhero of sustainability. What exactly does this algorithm do?
Well, imagine a factory that wants to maximize its profit while minimizing its environmental impact.
Okay, got it.
That's where multi-objective optimization comes in. You're trying to find the best trade-offs between different goals. Traditional methods struggle with complex systems, but MOBONs is designed to handle things like feedback loops and recycle streams, which makes it really good for tackling real-world sustainability challenges.
That's really impressive. Now, what about situations where we don't have tons of data to train these AI models? I mean, data scarcity is a real issue in a lot of fields.
Oh, absolutely. That's where prediction-powered adaptive shrinkage estimation comes in. They've developed a method called PAS that can make the most of limited data.
So how does it work?
It kind of acts like an expert guide, It sifts through messy data to find the really valuable insights.
Like finding a needle in a haystack.
Exactly. It combines predictions from machine learning with the reliability of high-quality data.
Okay, so even with limited data, we can still get value in insights. Now, this need for efficiency extends to the way AI models learn, right? I mean, imagine if we could train AI without needing tons of labeled data.
Right. That would be a game changer. And that's exactly what distribution matching for self-supervised transfer learning is all about.
Interesting.
This paper introduces distribution matching, or DM for short, which allows AI models to learn from unlabeled data more effectively.
So what does that mean in practical terms?
It means we could train AR systems on massive amounts of data without having to manually label everything, which would save a ton of time and resources.
That makes sense. It seems like we're just scratching the surface of what AI can do.
Oh, definitely. And up next, we're going to dive into some research that's even more mind-bending, like AI that can understand the passage of time and the potential for AI to become our digital twins.
Wow, this is getting deep. I can't wait.
Welcome back. Ready to explore some more cutting-edge AI research?
Absolutely. You mentioned AI understanding the passage of time. It sounds almost philosophical. Can AI really grasp that concept?
Well, that's what researchers are trying to figure out. This paper, Does Time Have Its Place? Temporal Heads, where language models recall time-specific information, digs into how well AI models can handle temporal information. Like, imagine an AI that can not only process information, but also understand its relevance in a timeline.
That's pretty mind-blowing. What are the implications of that? I mean, what could we do with AI that understands time?
Oh, the possibilities are endless. Think more accurate predictions, a deeper understanding of cause and effect. It could even change how we understand intelligence itself. And speaking of big questions, there's this paper, How Far Are LLMs from Being Our Digital Twins?, that explores the idea of AI becoming, well, us.
Digital twins? It's fascinating, but kind of creepy, too. What are the ethical implications of that?
Oh, there are a lot of ethical considerations to work through as this technology develops. But for now, the research is focused on how AI can model individual behavior, which could lead to some really interesting applications like personalized recommendations, simulations, maybe even virtual companions.
From the philosophical to the practical, let's talk about a paper that could have a real impact on self-driving cars. Reliable explainability of deep learning for improved semantic segmentation in autonomous driving. Explainability is a big deal in AI right now, isn't it?
Yeah, it is. We want to know why AI is making the decisions it makes, especially when it comes to something like self-driving cars. This paper looks at how we can make those decisions more transparent.
So it's not just about the AI making the right decision, but also being able to explain why it made that decision. That makes a lot of sense. Okay, now for something completely different, this paper has a title that sounds like it's straight out of a sci-fi movie.
Which one is that?
Synergistic fusion of multi-source knowledge via evidence theory for high-entropy alloy discovery. What on earth does that even mean?
Haha, yeah, it's a mouthful. But basically, it's about using AI to discover new materials, specifically high entropy alloy, which are these mixtures of multiple metallic elements.
And why are those special?
They can have some really incredible properties, increased strength, corrosion resistance, stuff like that. The challenge is finding the right combination of elements for a specific application.
Sounds like trying to find a needle in a haystack. How does AI help with that?
Well, this research uses AI to bring together knowledge from all sorts of different sources, like experimental data, scientific literature, even human expertise. It's like a collaboration between humans and AI to unlock these new materials.
That's really cool. It seems like AI is not just about developing algorithms, but also about using them to explore new frontiers in knowledge.
You got it. And we've got even more groundbreaking research to cover, but we'll have to save that for the next segment.
And we're back for the final stretch of our deep dive into the world of AI.
It's amazing how much ground we've covered already, but there's still so much more to explore. AI research is like a constantly expanding universe.
Let's jump right in. What other fascinating discoveries have caught your eye?
One that really stands out is this paper called Sleep GMU Former, a gated multimodal temporal neural network for sleep staging. It's about using AI to analyze sleep patterns and potentially diagnose sleep disorders.
AI analyzing our sleep, huh? How does that even work?
Well, they're using this type of neural network that's designed to handle multimodal data. Basically, it can take in information from different sources, like heart rate sensors, motion trackers, even brainwave readings.
Ah, so it gets a more complete picture of what's happening during sleep.
Exactly, and that allows it to identify different sleep stages more accurately and potentially spot any problems that might be going on.
So this could be a really valuable tool for doctors and sleep specialists.
Oh, absolutely. AI is already making a huge impact in healthcare, but it's important to remember that it's not a perfect solution. There are always limitations and potential risks to consider. And that brings us to the paper is Q-learning an ill-posed problem.
Q-learning. Now remind me what that is again?
It's a popular algorithm used in reinforcement learning. That's where AI agents learn through trial and error, kind of like how we learn from our mistakes.
Right, right.
But this paper is raising some questions about the stability of Q-learning, highlighting the importance of designing these systems carefully, especially in high-stakes situations.
So it's a reminder that AI is powerful, but it's not magic.
Exactly. We need to be thoughtful about how we develop and deploy these systems, but that doesn't mean we should shy away from exploring new possibilities. Like this paper, S-Test Time Scaling for Code Generation, which introduces a framework for making AI-generated code better.
Wait, AI that can write code. That's pretty wild.
It is, and this framework helps the AI generate multiple solutions and then pick the best one based on things like execution speed and code quality.
So it's not just writing code, it's optimizing it too. That's incredible. It seems like AI is touching every aspect of our lives, from healthcare to software development and beyond.
It really is. AI is more than just algorithms and data. It's a whole new way of thinking, a new way of understanding the world around us.
Well, you've certainly given us a lot to think about today. Thanks for taking us on this journey through the world of AI research.
It's been my pleasure. And to our listeners, remember, the world of AI is constantly evolving. Keep exploring, stay curious, and never stop questioning the boundaries of what's possible.
That's it for today's deep dive. Until next time, stay informed and stay engaged. The future of AI is unfolding right before our eyes.